Have you ever wondered what true silence actually feels like? I'm not talking about just a quiet library, but the complete, total absence of sound and echo. Well, today we're stepping inside one of the most surreal and scientifically vital environments on the entire planet. Imagine walking into a room, and that familiar sense of space, it just vanishes. The air feels heavy. You get this strange pressure on your eardrums. And as audio expert Martin Schneider points out, it's not something being added. It's the sudden, shocking absence of something we totally take for granted, reflected sound. So this completely bizarre feeling, it brings up a really cool question. What and where is the quietest place on Earth? Now, the answer isn't some remote cave or the bottom of the ocean. It's a room that has been engineered to be a perfect void of echoes. To really get this, we've got to break down what an anechoic chamber actually is. And, the clue is hiding right there in the name. The word anechoic literally just means non-reflective, or, without echoes. These chambers are painstakingly designed to absorb all waves, whether they're sound waves we can hear or invisible electromagnetic waves, creating what scientists call a free field condition. It's like the closest you can possibly get to being in a totally infinite open space. So just how quiet are we talking? It's so quiet that after just a few moments, you start to hear the internal workings of your own body, your heartbeat, the blood rushing in your ears, even your joints creaking. It's wild. The quietest one ever built, over at Microsoft, measured a mind-boggling negative 20.6 decibels. Now, to put that in perspective, the absolute threshold of human hearing is 0 decibels. So you aren't just hearing silence, you're hearing what's below silence. Think about that for a second. Okay, so creating this insane level of silence, it's not simple. It's a total marvel of physics and engineering. So how do they actually pull it off? Yeah, the first thing you notice in these rooms are the walls. They're covered in these huge kind of weird-looking foam wedges, but their shape is pure function. When a wave hits them, it gets trapped between the pyramids, bouncing back and forth and losing energy with every single bounce until, poof, it just dissipates into heat. They're designed to literally swallow energy whole. Now here's a really crucial point. While these rooms might look similar, they actually serve two totally different purposes. Acoustic chambers, the kind we've been talking about, they're for sound, but the other type, RF anechoic chambers, they're built to absorb invisible radio frequency waves, the very signals that power our entire wireless world. And an RF chamber, it's way more than just foam on the walls. It's this whole complex system. The entire room is basically a Faraday cage to block any outside signals. It has specialized filters for any power lines coming in, a massive vault-like RF-shielded door, and inside you'll see a turntable and an antenna mast to test a device from every single angle imaginable. All right, this is where it all clicks. This is the aha moment, because these strange, silent rooms, they aren't just some weird science experiment. They are absolutely essential to the technology you use every single day. Which really begs the question, right? Why on earth would we go to all this trouble to create a space that's completely silent, electromagnetically speaking? Well, the answer is actually pretty simple. We live in a world that is just saturated with electronic signals. I mean, think about it. Your phone, your Wi-Fi, your car, your microwave, they're all constantly broadcasting. An anechoic chamber is where engineers make sure all these devices can coexist and play nice together. It's a concept called electromagnetic compatibility, or EMC. Basically, it's how they guarantee your phone call isn't going to interfere with an airplane's navigation system. And yeah, EMC testing is the biggest reason these chambers exist. It's a huge slice of the pie. But they're also super critical for measuring the stealthiness of military aircraft. That's a metric known as radar cross-section. And for fine-tuning the antennas in everything from giant satellites down to the smartphone in your pocket, making sure you get a clear signal. Now, the technology inside these chambers has evolved just as fast as the devices they're testing. The way we do these measurements has gone through a complete revolution. Back in the day, testing was this incredibly slow manual slog. Engineers used a method called termination VSWR. And get this, They could only test one single frequency at a time. Today, modern methods just sweep across the entire spectrum in one automated pass. Seriously, what used to take days of agonizing work can now be done in just minutes. And just listen to how painful the old method was. You'd have to physically roll a cart around with the antenna, tune everything by hand, record one wave, move the cart, record another, and then do it all again. And after all that, you'd have to crunch the numbers yourself from 4 different values. It was powerful, but man, was it slow. The real game changer was the invention of the Vector Network Analyzer, or VNA. This one device, hooked up to a PC, it just replaces all those moving parts and manual tweaks. It can send and receive signals across a massive range of frequencies almost instantly. And it doesn't just give you data, it gives you phase information, which lets you do all the sophisticated digital filtering. It was a quantum leap in speed and accuracy. No exaggeration. So what does the future hold for these ultra-quiet spaces? Well, as our world gets electronically louder and more chaotic, the need for this kind of engineered silence is just exploding. And I do mean exploding. This is not some tiny niche market. In 2024 alone, we're talking about a market for anechoic chambers valued at over $2.3 billion. That's a staggering amount of money being invested in silence. And look at this, the demand is just soaring. Projections show this market more than doubling to nearly $6 billion by 2034. That trend line tells you everything you need to know about how critical this technology is becoming. So what's behind this massive growth? Well, it's pretty much all the tech that's going to define our future. You've got the huge rollout of 5G and soon 6G networks, the explosion of the Internet of Things, smart everything, the super complex systems inside self-driving cars, and of course, cutting-edge aerospace and defense tech. Every single one of these things has to be tested with more and more precision. Which leaves us with one final thought to chew on. As our world becomes this constant, invisible storm of signals, an electromagnetically louder place than ever before in human history, you have to wonder, are these perfectly silent, echo-free rooms becoming the most important laboratories we have?